Welcome back, dear students. So today we will be learning how to solve homogeneous equation from a differential equation. Now what is homogeneous equation? We need to understand that. Suppose let's say that there is a differential equation given to you. Okay. Now if you find dy by dx from that differential equation, okay, so find what is dy by dx from the differential equation, and when you simplify and find dy by dx, and if you can write your result in the form of y by x, if you can find your result or dy by dx in the form of y by x, or sometimes x by y, then such kind of equation is known as homogeneous equation. Okay, homogeneous differential equation. Now the thing is, how to solve homogeneous equation? Okay, so for that there is a special rule which says if you have y by x, then you can take y equals to vx. So this is the substitution that you are going to do. Okay, so you will take this, or if you have x by y, basically the role of x and y will get changed. So you take x equals to vy. Okay, so these are the two different things. Now if y is equals to vx, then what you are going to do is you will differentiate with respect to x. So when you differentiate, you get dy by dx. Now you have product of two functions, so keep v as it is and differentiate x. So differentiation of x is 1, so v into 1 is v itself, so we have plus. Now keep x as it is and differentiate v. So when you differentiate v, you get dv by dx. So this is the rule that you need to follow. Okay, and later on what you will do is you will substitute dy by dx out here, you will substitute y equals to vx out here. Simple. Similarly you will do the same here. What you will do is you will differentiate both sides with respect to x, with respect to y. Remember, with respect to y. Okay, so in that case what you will get is you will get dx by dy. By the way, sometimes what you have is you will represent dx by dy as g of x by y. That time you will apply this rule. Okay, so differentiate both sides with respect to y, so you get this much. Okay, so you get this much. So these are the rules that you need to follow while solving homogeneous equations. Haven't understood? Alright, then let's see one problem for better understanding. So here we have to find the general solution of each of the following. So the first question says x square y dx is equals to x cube plus y cube dy equals to 0. Okay, so let's quickly solve this. Now what will I do is I'll find dy by dx, as I said. So from here we see that this goes out there, so it becomes x cube plus y cube dy is equals to x square y dx. Okay, now so here what will I do is keep dy and get dx out here, because I said I want to find dy by dx. Okay, now here you are left with x square y by you have x cube plus y cube. Okay, now I said dy by dx has to be represented in the form of dy by dx has to be written as f of y by x. So here you must have y by x, here also you must have y by x. Now in order to get y by x, what will I do is I will divide numerator and denominator by x cube. Okay, so let's see what do we get if I divide both numerator and denominator by x cube. So in that case we get, so in the numerator we have x cube by x cube, I'm sorry, not x cube, it's x square y by x cube in the numerator, divided by in the denominator we will get x cube by x cube plus y cube by x cube. Alright, now you see few things get cancelled. For example, here this and this gets cancelled, so in the numerator you will have y by x, this and this gets cancelled, you have only 1 left. So can I write this as, just look at this carefully, can I write this as y by x divided by 1 plus y by x whole cube? Yes. Now see, this right hand side is a function of y by x, isn't it? See, I have written y by x, I have written y by x. So I don't have anything apart from y by x as the variable. So we have shown, or we have got dy by dx as a function of x, y by x. Now that means it is a homogeneous equation, isn't it? Now as per the rule, we need to do some substitution. Yes, so let me do the substitution. So let y equals to vx. So this is the substitution that you need to make. So from here, you know, you get dy by dx is v into x dv by dx. So this is what you get. Okay, so let me erase this part. All right, so now let's resubstitute out here. Okay, so therefore we have, okay, so in place of dy by dx, let me write v plus x dv by dx is equal to, so y by x. Now see here carefully, if y is equal to vx, then tell me what is v? V will be y by x, isn't it? So that's why from here you get, see here, this becomes y by x becomes v by 1 plus v cube. Y by x is v. Okay, now take this v out there and let's see what do we get. So we get v, I'm sorry, not v, it's x dv by dx is equals to v 1 plus v cube minus v. Okay, now let's simplify this. Now when you simplify this, this becomes, so in the denominator we have 1 plus v cube, so in the numerator we have v minus, now v into this quantity becomes v minus v to the power 4. See, these two gets cancelled. So from here what do we get? We get x dv by dx is equals to minus v to the power 4 by 1 plus v cube. Okay, now this looks like differential equation of variable separable type, because you can separate the variables out here now. Okay, so if I separate the variables, so this v, if I take this to the left hand side, you get 1 plus v cube by v to the power 4 dv is equals to minus, so let me get that dx out here and this x goes to the denominator. Okay, let me simplify this further. So you know, you can write this as 1 by v to the power 4 dv plus this can be written as v cube by v to the power 4 dv is equals to minus dx by x. Okay, now you can integrate both sides, and before that you can cancel them. Okay, so integrating, just wait a minute guys, so integrating both sides, so let's integrate both sides. So this becomes v to the power minus 4 dv plus this is integral dv by v is equals to minus integral dx by x. So that's what we get. Okay, so I don't have space here, you may pause the video and note down your solution till here. Okay, then now just look at this. So integral v to the power minus 4 becomes v to the power minus 4 plus 1 divided by minus 4 plus 1 plus this is log v, right, log v is equals to minus integral dx by x is log x. Now as we are done with the integration, let's put a constant of integration out here. Okay, now just observe this carefully. So this is minus 3. Okay, so this becomes minus 3 by v cube. Okay, plus you have log v is equals to, or you get this minus out here, you get plus log x is equals to c. Now let's put the value. Okay, so we have minus 3 by v. What is v actually? V is y by x, isn't it? So let me write y by x out here, and we have cube. Okay, plus similarly we have log y by x plus we have log x equals to c. Okay, so from here you get minus 3x cube by y cube. Now this is log a plus log b. All of you know log a plus log b is log ab. So that's why if I combine them, you get log a into b is equals to c. Here also these two gets cancelled. So that's why your final answer turns out to be minus 3x cube by y cube plus log y is equals to c. So this is the general solution. Okay, so this is the general solution of the given differential equation. Alright, so just wait a minute. There is a small mistake, I guess. So the mistake that I have done here is this 3. Okay, so this 3 will be in the denominator. Okay, so please make a note of it. This 3 is going to be in the denominator. Not in the numerator. Okay, so in the numerator we are just going to have 1. Alright, so we have 1 here, so 3 goes out here. So 3 will be here, 1 will be here. So we have 3, we have 3 here. Okay, so this is your answer. Okay, I'm sorry for the mistake. Now let's move to next question then. Okay, so next question is on the screen, which says, alright, by the way, let me go back to the earlier problem. Okay, so you know, in earlier problem what you have done is you have written, let me write it here. You have written dy by dx is equals to x square y by x cube plus y cube, isn't it? So you know, what we have done is we have divided both numerator and denominator by x cube, but without dividing also we will be able to know whether this is homogeneous or not. So for that, what you need to do is you have to look at the degree. Okay, look at the degree means power of both the numerator and denominator. It has to be same. Now what is the degree of numerator? It is x square. Now what is the power out here? Power is 1, so x square, that is 2, and 1 gives you how much? 3. So in the numerator power is 3, and similarly in the denominator we have 3. Now this plus doesn't play any role. Okay, and here also you have got 3. So both of them have got the power 3, so that's why the denominator also has the power to be 3. So if the power of both numerator and denominator are same, then such kind of equations are also considered to be homogeneous equation. So we are going to check this way in the next problem. Okay, so in the next problem we have this one given to us. Let's quickly find what is dy by dx. Okay, now so first take dx out there, so you get x dy is equals to, now you get y plus square root of x square plus y square dx. Okay, now do the separation, so you get dy by dx is equals to, you have, okay, so you have y plus square root of x square plus y square divided by, you have x, isn't it? Okay, now in the denominator power is 1. Now here it is square, this is square, but due to square root power becomes 1. So I said plus doesn't play any role, so here also power is 1, here also power is 1, so it means altogether numerator has power 1, also denominator is also having power 1, so that's why this becomes your homogeneous equation. You can call this to be equation number 1. Okay, so let y equals to vx. Let me take this substitution. Okay, so therefore from here you get y is, okay, so from here you get dy by dx is equals to v plus x dv by dx. This is by differentiation. So therefore 1 becomes, let's see what do we get. So dy by dx is v plus x dv by dx, right, is equal to, now let's see what happens out here. Y is vx, remember y is vx, plus you have x is, just wait a minute, you have x square plus y square. Y square becomes v square plus v square x square, right, divided by, you have in the denominator x. Okay, so here what is common that you see out here? It is a x square, right? X square is common, and due to square root, that x square becomes x. So can I write this as, see here carefully, we can write this as vx plus x square root of 1 plus v square divided by, we have x. Now again you have x common, take x common, x and x gets cancelled. So from here what you are going to get is, you'll get v, from here you get v plus x dv by dx will be equals to, so cancel x, you get v plus root over 1 plus v square, simple. So v and v can be cancelled. So from here you get x dv by dx equals to this much. So do the cross multiplication, or you do the separation of variables, so you get this much. Okay, now integrating both sides. Let's see what do we get after integration. So after integration you get integral dv by root over 1 plus v square is equals to integral dx by x. Okay, now can I write this as a in the form of a square plus x square? Yes, obviously, right? And all of you know that this will be equals to, this integral will be equals to log v plus root over 1 plus v square is equals to, this is log x. Now put constant of integration as log c, that will be better. Okay, now what we will do here is, now we will put the value of x, of v. Okay, v is y by x, all of you know. So similarly this is also 1 plus y square by x square. Okay, now this becomes log xc, right? Okay, now see here carefully. So what am I going to do is, you can find the LCM if you want to. Okay, so if you want to find the LCM, what you will get is log, you get y by x plus, here you are going to get x square plus y square by x. Now how x? Because of square root, actually we get LCM is x square, but because of square root this becomes x. Okay, is equals to log xc. Now just cancel log and log. So what you will get here is simple. See here carefully. What you are going to get is, so I don't have space, let me do it here. So from here you will get, okay, so let me simplify this also at the same time. So in the denominator you have x plus y plus root over x square plus y square will be equals to xc. Okay, so from here do the cross multiplication, you get y plus root over x square plus y square is equals to x into x is x square c. So this is the general solution of the given differential equation. Okay, so you may pause the video and note down your solution. Now let's look at this particular problem. So in this question, so it is given in the form of x by y. So what will I do is, I'll find dx by dy in this case. Okay, so before we find dx by dy, let me take minus common out here. So you get 2y e to the power x by y dx minus, so when you take minus common it becomes 2x e to the power x by y minus y dy is equals to 0. That's what you are going to get. Now bring this out here, so you get 2y e to the power x by y dx is equals to, so take it out there, so you get 2x e to the power x by y minus y dy. And my aim is to find, remember, x by, since it is given in the form of x by y, we have to find dx by dy. So bring this dy out here, take this to that side. So you get dx by dy is equal to, so we have 2x e to the power x by y. Okay, now bring this out here, so you get 2y e to the power x by y minus y by, we have 2y e to the power x by y. Simple. Alright, so we see few things are getting cancelled. 2 and 2a gets cancelled. This will get cancelled with this. Here this and this gets cancelled. So from here we get, it is dx by dy is x by y minus, so half, we can write this as e to the power minus x by y. Now see, dx by dy can be written in the form of x by y, isn't it? So in that case, the substitution that you need to make is, you have to take v equals to, you have to take x equals to vy, right? Now differentiate, you get, differentiate with respect to y, so you get dx by dy is equals to v plus y dv by dy, isn't it? Now let's substitute this in this. So in that case, what you are going to get, let's see. So therefore we have dx by dy can be written as v plus y dv by dy, okay, is equal to, so x by y. So from here, what is x by y? From here you get v equals to x by y. So in place of, x by y, I'm going to write v. So you get v minus half e to the power minus v. So v and v gets cancelled. Okay, now you can do the transfer of the variables. Okay, separation of the variables. So we have v here, so bring this v out here. So actually it is 1 by e to the power v. So when it comes out here, it becomes e to the power v dv is equals to, minus half is already there, so it becomes dy by y. Okay, so integrating, we get integral e to the power v dv is equals to minus half integral dy by y. Okay, now see here carefully. So integral e to the power v dv, how much is this? It's e to the power v, right, is equals to minus half, this is log y. Now put a constant of integration. Now let's put the value of v. V is x by y, isn't it? So you get e to the power x by y is equals to minus half log y plus c. So this is the required general solution. Alright, so you may pause the video and note down your solution. Chalo, let's move to the last question for the day. So we have on the screen in the form of y by x. So whenever it is in the form of y by x, we will find dy by dx. Okay, so let's find dy by dx from here. So first and foremost, take this out there. Okay, so when you take it out there, in the right hand side, whatever is in the right hand side, I am writing in the left hand side. So you get x into y sine y by x minus x cos y by x dy is equal to, so you get y x cos y by x plus y sine y by x dx. Now bring this dx out here and take this to the denominator. So you get dy by dx equals to, so you have y x cos y by x plus y sine y by x, okay, divided by, so this everything goes to the denominator, so you get x y sine y by x minus x cos y by x. So that's what you are going to get. Y by x, it's in the form of y by x, so no need to worry. So what you can do here is, see here carefully, what you can do here is you can directly substitute what is the substitution that we need to make. Obviously, since it is in the form of y by x, we will do the substitution y equals to vx. Okay, so from here you get dy by dx will be v plus x dv by dx. So this substitution will be made out here. Okay, so therefore we get, okay, so we get also, remember, v will be equals to y by x. Okay, now simplify this. Now in place of dy by dx, I am going to write v plus x dv by dx is equals to y. What is y actually? Y is vx. So y is vx. So x cos y by x is v plus y is vx sine, we have v by, we have x, y is vx, so sine y by x is v minus x cos v. So that's what we will have in the denominator. Now see what is common in the numerator. I see x is common. Okay, I see x is common out there. So you, when you take x common, it becomes vx square cos v plus v sin v. Okay, divided by, you have x square v, x square, it becomes x square v sin v minus cos v. So that's what you are going to have in the denominator. X square can be cancelled. Okay, now bring this v out here. So when you bring this v out here, then you get, okay, so you get x dv by dx will be equals to, see here carefully. So you have, let's open the bracket at the same time. So we have v cos v plus v square sin v by, you have v sin v minus cos v, isn't it? Now it comes out here and becomes minus v. Okay, now simplify this. So this becomes v cos v plus v square sin v minus, okay, now see here carefully. Now see, all of you know LCM is, all of you know that LCM is the same. Okay, that is v sin v minus cos v. Okay, now when you multiply this LCM with this, you get v square sin v plus v cos v, isn't it? Right? Now here some things are getting cancelled. For example, this, just wait a minute, this is just sin v. Okay, so this and this gets cancelled. V cos v plus v cos v is 2 v cos v divided by, we have in the denominator v sin v minus cos v. So this is the value of x dv by dx. Now here what will I do is, I will do the separation of variables. So get all this v to the left hand side, you get v sin v minus cos v by 2v cos v dv is equals to dx by x. Now separate the variables. So you get v sin v by 2v cos v dv minus cos v by 2v cos v dv is equals to dx by x. Okay, now I'm not going to complete this problem, you will complete it by yourself, but only thing that I can do here is I'll do the simple simplifications. Okay, so when you simplify this, this becomes, let me write it here. So it becomes, let me write it within this. Okay, so this becomes sin v by cos v is tan v, right? So it becomes half tan v dv is equals, I'm sorry, there's minus, so this becomes 1 by v, 1 by 2 dv by v is equals to dx by x. So that much I have done. Now from here onwards you can try by yourself. Integrate. After integration, put constant of integration. After putting constant of integration, you can put the value of v, which is y by x, and after that whatever you get, that will be your general solution for this particular question. Okay, so you may pause the video and note down your solution. So here I have got two homeworks for you, so you may pause the video and note down your homework and the answers as well. Okay, so with this we close for the day. Thank you very much.